Hello everyone, this is Mr. Fawcett, and we are back for part 2 of our conditional statements lesson. We'll see if we have to make this into 3 parts. It is a chunky lesson, but we'll see if we can squeeze it all into the second part. We're going to go down here. We left off by underlining the hypothesis of each of these conditional statements. So just a quick reminder, when we have a conditional statement, we have something that is in the form if-then. So an example would be, if you score a 90%, then you receive an A. So in this case, our hypothesis would be if you score 90%, that would be our P, right? Because our conditional statements are in the form P implies Q. That arrow just means implies. And then our hypothesis would be, then you will receive an A. That would be our Q. So we're going to practice writing some of these today, practice understanding them. So let's just jump right in. So on the next page, we are given some statements and or diagrams, and we need to write a conditional statement for them. So think about what should be your hypothesis, think about what should be your conclusion. We will do you can try these actually before we go through one, but if you want to see how we put these into conditional statement form, you can just watch number 1. So number 1 says the midpoint of segment M bisects segment M. And we've talked about this in a previous unit, but if we have a midpoint, right, if here's my segment and I have a midpoint, well, bisecting would mean that both individual segments are congruent to each other. So to turn this into a conditional, we're going to add an if-then. So if a point is the midpoint of segment M, then it bisects segment M. So we've just turned it into a conditional statement. Okay, so you're going to work through number 2, 3, 4. Let's see, do I have one more for you? No, just 2, 3, and 4. But then you are going to write your own conditional statement and circle the conclusion. You can write about whatever you want. I would make it something that's interesting to you. I would make it something that makes sense. So I wouldn't write a conditional statement that says, if the color is red, the animal is a tiger, or something that just doesn't make any sense. And then we'll discuss 2 through 4, and maybe I'll give you one of my own. Okay, so number 2, we have a Venn diagram, and the large circle is representative of spiders, and the smaller circle inside is tarantulas. And if you're unfamiliar with tarantulas, that's just a specific type of spider. So if the animal is a tarantula, then it is a spider. And you could think about saying it the other way around and think about whether it would make sense that way. So you could say if the animal is a spider, then it is a tarantula. But that doesn't necessarily make sense, right? Because if the animal is a spider, then it could be a black widow, right? Or it could be some other type of spider instead of a tarantula. But if the animal is a tarantula, then it 100% has to be a spider. Okay, number 3 says 2 angles that are complementary are also both acute. So I'm going to pause the video and put it on there. So if 2 angles are complementary, then they are also acute. Let's move on to the one about birds. So we have, if an animal is a blue jay, then it is also a bird. Now, if you had said, if an animal is a bird, then it is also a blue jay, that would just be a false conditional statement, right? Because if an animal is a bird, well, then it could also be a cardinal, or it could be a mockingbird, or it could be a parrot, or some other type of bird. But if it's a blue jay, then it 100% has to be a bird. So this would be the true conditional statement based off of that diagram. All right, and we'll come up with one of my own. You should have one of your own on the paper. So I said, if you watch this video, then you will understand conditional statements. And I need to circle the conclusion. So I'm just going to look for the part after then. And that is this right here. So the if you watch this video would be our hypothesis or our P, and what I circled would be our conclusion or our Q. All right, let's move on to the next page. So what we did was just practice writing conditional statements. Now we're going to talk about how to analyze the truth value of conditional statements. Okay, so I just added a conditional statement down here because we're going to use it to talk about these statements up here. So the only time a conditional statement is false is when the hypothesis is true, but the conclusion is false. So if you can find an instance where the hypothesis is true, but the conclusion is false, then you can say that the entire statement is false. So if we look down here, where it says, if you score an 80%, then you will pass the exam. So if you could find an example where someone scored an 80%, but they didn't pass the exam, then this conditional statement would be false. Number 2 says, if the hypothesis is true and the conclusion is true, then the truth value of the statement is true. And that makes sense, right? If we think about the statement, if you score an 80%, so if you find someone that scores an 80% and you know that they passed, then the statement's true. Well, that makes sense because that's what it says is going to happen. Let's look at this third one. If the hypothesis is false and the conclusion is true, then the truth value of the statement is still true. So let's think about how this would occur with this conditional statement. So my hypothesis is the first part, if you score an 80%. So let's say that's false. So let's say they scored a 90%. Okay, so they didn't score an 80%, they scored a 90%. Well, what about the conclusion? So could you still pass with a 90%? Well, of course you could, right? If you're going to pass with an 80%, then you are sure going to pass with a 90%. So it's possible for the conclusion to be true, but the hypothesis to be false. And it doesn't mean that the entire statement is false. So hypothesis can be false, conclusion can still be true, right? We don't know that the conclusion is going to be true, right? Because somebody could score a 50% and not score an 80%, and then they wouldn't pass the exam. But that's irrelevant because our hypothesis was that they scored an 80%. So we only have to analyze this statement if the hypothesis is true. So if the hypothesis is true, then we have to make sure that our conclusion is true. But if the hypothesis isn't true, well, then our conclusion could be true or false, and it doesn't matter, right? That's what gets into number 4. So if the hypothesis is false and the conclusion is false, then the truth value of the statement is still true, right? And that goes back to my 50% example. If somebody scores 50%, then that makes the hypothesis false. And if they didn't pass with the 50%, it also makes the conclusion false. But it doesn't make this entire statement false, right? Because all this statement is saying is that if you score an 80%, then you're going to pass the exam. It doesn't mention what happens if you don't score an 80%. Okay, so the only time that this conditional statement is false is if the hypothesis is true and the conclusion is false. right? So if someone scores an 80%, but they didn't pass the exam, then this statement wouldn't make any sense. It would be false. Okay, let's get rid of that. And let's do some practice. So it says determine whether each conditional is true or false. If the conditional is false, be sure to provide a counterexample. So the only thing that we need to look for is a circumstance where the hypothesis is true, but the conclusion is false. So if that scenario ever occurs with one of these statements, then the entire statement is false. So let's look at number 1. If today is Sunday, then tomorrow is Monday. Well, if today is Sunday, will tomorrow ever not be Monday? Right? Will tomorrow ever be Tuesday? No, it won't. Tomorrow has to be Monday. So when our hypothesis is true, our conclusion, tomorrow is Monday, is also always going to be true. So this is a true statement overall. Let's look at number 2. If an angle is obtuse, then it has a measurement of 100 degrees. So is there ever a case where an angle is obtuse, but its measurement is not 100 degrees? Well, of course, right? Because I could have a 120 degree angle. That angle is obtuse, but its measurement is not 100. So if the hypothesis is true, but the conclusion is false, then this whole thing is a false statement, right? Because I could have this hypothesis be true, but the conclusion, right, the angle does not have to always be 100 degrees. It could be 120, it could be 121, etc. Number 3, if an odd number is evenly divisible by 2, then 8 is a perfect square. Well, will an odd number ever be evenly divisible by 2? Okay, well, that's never going to be true. So our hypothesis right away is false. And if our hypothesis is false, remember, it doesn't matter what our conclusion says, right? Our conclusion is also false. 8 is not a perfect square, but it doesn't matter because our hypothesis was false. So this entire conditional is true. And that goes up to what we were talking about up above, right? The only time a conditional statement is false is when the hypothesis is true, but the conclusion is false. For any other scenario, the statement will always be true. Okay. We are actually going to make this lesson 3 parts. I think this is a good breaking point because I'm about to introduce some more vocab. I don't want to introduce it and then have a break in the video before we practice. So hold tight here. We will come back for part 3 and finish off this lesson. Until then, enjoy the rest of your day.